the Department of Electronic and Communication Engineering at Srinivasa Ramanujan of Technology. Today I am going to present my continuous alternative assessment 2 on the subject electronic devices and circuits. The topic of my presentation is construction, principle and the operation of N-channel JFET. In this session, I will explain how an N-channel JFET is constructed, discuss its working principle, describe the different modes of operations, and highlights its characteristics and applications in the electronic circuits. Contains introduction, symbol of N-channel JFET, construction, principle of operation mode, output characteristics, transfer characteristics, advantages, applications, conclusion. Introduction. A N-channel JFET is a semiconductor device with an N-type semiconductor channel for current flow, bounded by two P-type regions forming the gate. It operates as a voltage control device using a reverse biased gate source voltage to control the channel's width and thus the current between the source and the drain terminals. This principle allows the JFET to act as an amplifier or electronic switch, controlling a large output current with a small gate voltage. Symbol of N-channel JFET. The symbol for a N-channel JFET has an arrow on the gate terminal pointing inward or toward the channel. The device has three terminals: gate, drain and the source, with the arrow indicating the direction of the gate current when the gate junction is forward biased. Key points of the N-channel JFET symbols: channel represented by a vertical line, gate an arrowing part pointing toward the channel, source and drain. The remaining two terminals connected to the vertical line. Construction of N-channel JFET. JFET is a unipolar device that uses only majority charge carriers for the current conduction. First one is structure. It is made of a highly doped N-type semiconductors bar. Two P-type regions are diffused on the opposite sides of the N-type bar. These P regions are electrically connected together to form the gate terminal. The two ends of the N-type bar are called source and drain. Source, where the carriers enter the channel, where the carriers leave the channel. Gate junction. The P-type gate regions from the PN junctions with the N-type channel. A reverse bias is usually applied between the gate and the source to control the channel. Third one is terminals. Source, drain, gate. Source supplies electrons, drain electron flow out of through it. Gate. Control the current flow by varying a reverse bias. Symbol. The arrow on the gate points toward the channel. For an N-channel JFET, key point. In an N-channel JFET, electrons are the majority charge carriers. Current flow ID is controlled by varying the gate voltages VGS, which changes the depletion region within the channel. Principle of operation. Principle of operation N-channel JFET. The operation of an N-channel JFET is based on the control of current through an electric field. It works on the principle that the width of the depletion layer around the PN junction controls the current flow through the channel. When the gate to source voltages is 0, a gate terminals are connected to the source. A small drain to source voltages VDS is applied. Electrons flow freely from the source to drain. When the reverse gate voltages is applied, PN junctions become reverse biased, winding the depletion regions. This reduces the effective width of the N-channel JFET. As a result, the drain current ID decreases. Principle of operation. Principle of operation is when the VGS. Third one is principle of when VGS equals to VP, the depletion regions touch each other and the channel closes. Drain current becomes nearly 0. Summary of operations. VGS equals to 0, that is maximum current. VGS less than 0, that is reduced current. VGS equals to VP, current cutoff. Key principle. If an N-channel JFET, the drain current ID is controlled by the electric field produced by the reverse biased gate to voltage source. Operation mode. The operation mode of N-channel JFET, that is the ohmic region, linear region. Condition is is a small and is less than negative. The JFET behaves like a voltage controlled resistor. The channel width is almost constant and the current increases linearly with used for the small signal amplification and analog control circuits. Summary: JFET has a variable resistor. Active or saturation reason condition is enough to cause pinch of the drain end, but the channel is not completely closed. The drain current ID becomes almost constant and it is mainly controlled by the saturation reason. This is the reason used for the amplifier operation. Summary: JFET as a voltage controlled current source. Operation mode. Third one is cutoff reason condition is equal to or less than the pinch of voltages. This channel is fully depleted, not current flows from the drain to source. The drain current equals to 0. Summary: JFET is off. Output characteristics. Characteristics of n-channel JFET. Definition: the output characteristics of n-channel JFET shows the relationship between the drain current and the drain to source voltage for different values of gate to source voltages. Circuit setup. The drain is connected to a positive voltage supply through a load resistor. The gate is reversed biased with respect to the source. VGS is varied, and for each the IDA is measured by VDS increases. Graph description: on the x-axis drain to source voltage, on the y-axis drain current. As a family of curves is plotted of different VGS values. Three regions of the graph: ohmic, linear region, saturation, cutoff region. Transfer characteristics of n-channel JFET. The transfer characteristics shows the relationship between the drain current and the gate to source voltages VGS for a constant drain to source voltages. It explains how the gate voltage controls the drain voltage. Axis of the graph: x-axis gate to source voltage, y-axis drain current. Shape of the curve: the curve is parabolic. At VGS equals to 0, the drain current is maximum. The VGS becomes more negative, the depletion region wanes and ID decreases. When the VGS equals to VP, this channel is closed, ID equals to 0. Mathematically relationship. Advantages of n-channel JFET: high input impedance, low noise operation, voltage control device, battery thermal stability, low power consumption. Conclusion: the n-channel JFET is voltage controlled unipolar device that uses electrons as majority charge carries. It provides high input impedance, low noise and excellent voltages of current. The drain current is controlled by the gate to source voltage VGS through the electric field effect because of its low power consumption and stability under the linear operation. It is widely used in amplified switches, analog circuits. Overall, the n-channel JFET is a key electronic device that combines simplicity, efficiency and reliability in modern electronic applications. Thank you, sir.